Start recording. Let's prove this one. $1,000 state rank. I'm saying it now. 2021. You guys get it? If you're even get above 97.
Hold on, is this just math or what subjects?
No, just math.
Okay.
Yeah, math. Extension 2.
Extension 1.
Extension 1, I think it might be harder to get. I haven't seen this on paper yet.
So
when I see it, I'll find out.
Is that like $2,000 or?
Good one. No. Extension 2, even extension 1, if you get state rank, I'm open to $1,000 done in your bank account the next day. That's it. I promise.
And if
Fair
you
enough?
get both, is that like double time or?
Done, double.
Oh, alright, set.
Set. Done.
Just so you know.
Carefully.
I'm just gonna.
We're not gambling.
I'm not gonna
It's
start
motivation.
now.
It's motivation. It's
So we get
seriously
$3,000
motivation.
in total. if
Sorry?
we top both of them.
Sorry?
So we get $3,000 in total if we top both of them.
No, $2,000. This guy's trying to throw it out. I like it. He tried. One minus.
You agreed to double time, so that means $4,000.
Get out of here. One minus omega power 4. 3. Omega 5 is omega squared. 2 if you do both. Extension 1, extension 2.
And if we come first in the state?
First, that is top state. Yeah. First is top in the state. Top rank. To come first in the state, pretty much you'd need to get 99
I'll get 100.
or 100. That's it. That's first in the state. Both will get scaled up to 100. So you got to get 99. That means you've only got room for 1 mark error, which is very doable, but you've got to really be, I think I'm going to say what another teacher said, widely read. So you got to expose, like I always said, just expose. Just go out and open up every example. Like this year's CWSA English paper was worded exactly the same as the HSC paper. How lucky are all those Catholic schools? Done. They got the exact same question. So now they're looking, there's something happening there? We don't know, we'll find out. But just saying, worded exactly the same. How is that even possible? For English, if it was math, we understand. English, ooh. Anyways, 1 minus omega, 1 minus omega squared, 1 minus omega, 1 minus omega squared. Do you guys agree with that? Can someone tell me what they can do in the next step?
Turn
Yes.
omega squared into 1, negative 1 minus.
You could. I'm going to just override it and say no. Yep. She said convert omega squared, if you guys didn't hear that. But I'm just going to say no. You could. I'm just going to say no. So next, look at it. There's something that's the same. So what would you usually do?
Probably simplify.
Simplify like how?
It'll be 1 minus omega squared.
Beautiful. I like that. That's the next step. 1 minus omega squared. You'd probably simplify it like this. Then again, you're thinking of expanding. Don't. Think of, if they're both squared, isn't it the same as me saying this? Isn't that the same? Now look, I've only got to expand 1 time. Well, wait, don't expand yet either. What are you going to do in the inside bracket? You're going to expand that first. 1 minus omega squared minus omega plus omega cubed squared. We're getting close. What's omega cubed? 1. 1 plus 1.
2.
Don't forget what we're trying to get. 9. What squared gives you 9? Ah. So somehow this guy's got to equal to? No, this thing has to equal to? 1. Yeah, pretty much. Omega cubed, or 1. If you rearrange the formula that you know of here, 1 equals minus omega squared. The answer is 2 plus 1, which equals to 9. Pretty cool, right? Don't think of expanding straight away for omegas. That's it. You're done with everything. I've seen another one that usually becomes 16. What do you think happened there? 4. You're going to get to 4. 4 squared. That's all. Or maybe you could even get 27. That was 3 cubed. But again, you don't cube it. That's the idea. Until the very end. Done.
So
That's
if
so.
you did expand it like so halfway through. Answer out.
Let's see. I don't know. It depends. Halfway through, do you mean this line?
No.
Look. Would you get the answer out?
Yeah.
100%.
Oh,
So forget that. That like if you're going to even start it from this line here, yeah, you'll expand. You'll have a lot of like powers of 4s, powers of 5s, which you'll simplify back. Eventually, you'll get to 9.
just next to
It's just not, I guess, yeah, the most efficient way. Cool. Done. We are up to our vectors and locus. Last 2. We did that. We've done that. We did De Moraes. There's locus, which we're going to do right now. And then vectors, which we'll leave because then that might just work well with our next topic. I might as well just start vectors right after this again. So we'll do our integration speed test from now on. So that's integration continuing. And then our next topic will be vectors again. Because I think that was probably the hardest section of this year's Extension 2 exam. All right, locus. They're not bad. Really, locus is not bad. That's it. That's all I'm going to say. There's the 1 or 2 off questions or type of questions. That's okay. You'll work on it. You'll focus on it. You'll master it. You're done. Just like max-min problems. We said they're a little bit tricky, whatever. Work on it. Give it some time. It becomes okay. Right. Let's do it. Let's first read and then talk to me if there's any questions. Circles. The length of a vector from a center of a circle to any point on the circumference has a modulus equaling to the radius. That makes sense. The modulus of z is equal to r. Essentially, that means the modulus of z is equal to r is a circle of radius r centered at 0. That means if I've got the modulus of z minus anything in brackets, then it's a circle of radius r centered at a and b. Positive. So that means if it was like this, z minus a minus ib, the center is the opposite, just as if like you were doing it back in advanced math. True? You were doing opposites always. So a, positive b. Some students of mine just tend to prove it. I even tend to prove it. I think this is the way we did it last year. I decided to make you guys prove them. Just do it. So the good thing with locus, you can get all of them out by letting z equal to x plus iy. So imagine I let z equal to x plus iy. Watch. If z is x plus iy, I end up with this. What is the, and then obviously you guys know what real and imaginary is here. So what's the modulus of something? How do we find the modulus of anything? What's the formula for modulus? Square root of x squared plus y squared. So in this case, it'll be square root of x minus a squared plus I is only there because it's telling you it's imaginary. Squared is equal to, there it is, you just proved it. Takes you 2 seconds to prove. Done? Ready? It makes sense? 100%. There's no reason why you're going to get any of these locus questions wrong, right? Cannot get them wrong. Because it's right there. If your worst case scenario, for any locus, just let it become z equal to x plus iy and prove it. Done. Now you know it's a circle. So here they are. Illustrate this. Z equals to 2. Again, we know the center is at 0, 0. Radius is actually 2, not square root of 2. It is 2. Why is it 2? Because I just proved it up here. The left-hand side becomes square root. So that means it's already square rooted. All right, done. 2. There it is, down here. The next one, minus 1, minus 2i. What does that mean? That means the center is at positive 1, positive 2. Why? Because again, think of it like this up here. It was going to be x minus a, y minus b. Then you know that the center of up here is a and b. Make sense, mate, yet?
Yeah.
Radius is 3. Now, can you see it's an inequality? What do we remember about the inequality?
It's shaded on the outside.
But why? But shaded, let's talk about shaded for a second, because I didn't mean that when I said inequality, but that's fine. Shaded, pick a point. Pick any point that's not on the line. So obviously you would pick the point x is, let's just say 0, 0. Right? Pick 0, 0. So what do we have? I don't know, 0, 0 minus 1 minus 2i is minus 1 minus 2i. So what's the modulus of this complex number? Square root of 1 squared plus 2 squared, which is root 5. Is root 5 smaller than or equal to 3? Yes, it is, because root 5 is about 2.1 or something, 2.2. So therefore you shade inside. So inside both. Or, because you're in 4 unit, and I think we can do this pretty fast, less than means inside. Greater than means outside. And I think that's just common knowledge. You'll see that, but don't risk it. As you're doing it right now, just keep testing. Cool. Until you become really good at it, you're like, I'm getting nothing wrong for the last 50 questions, then I think you can start doing what I just said. If it's less than and equal to, full circle. If it's less than or greater than, dotted, we remember. So please, remember that. That's got to be dotted. You lose 1 mark if it's not. Okay, move on. Perpendicular bisector. It's true. If one modulus is equal to another modulus, then it's like this. The length of the vectors from any point on a perpendicular bisector to the 2 points have the same modulus, so the perpendicular bisectors are blah, blah, blah. What are you guys doing? Why are you memorizing that? You don't need to. It's good, but you don't need to. Here it is. Sketch z minus 4, z minus 2i. So, you know, there's 2, there's 4. It's the perpendicular bisector of the interval joining 4, 0, 0, 2. That's great. A lot of people get that. Great. Sam doesn't. Sam's going to do it like this. Z is x. The reason why I teach it like this is because today it's a modulus equal to a modulus. Tomorrow it could be a modulus equaling to 3 times the modulus. It's no longer a perpendicular bisector. It's an ellipse, for example. So like, you can't do this. You can't just half cut mask stuff. So what's the fail-safe method? Z equals to x plus iy. So we're going to do it. X plus iy minus 4 equals x plus iy minus 2i. All right, modulus, square root, x minus 4 squared plus y squared equals square root, x squared plus y take away 2 squared. What do you do to both sides? Square root, square it, go on. X squared minus 8x. Come on, is this that much harder? Like, I mean, it's good. You can memorize perpendicular bisector of the interval joining 4, 0, because it is, and 0, 2. And interval perpendicular, which means you've got to find the gradient of 2 and 4. And then, you know, blah, 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 blah. But, like, look at my version. Fail safe. And plus, it improves your math, doesn't it? There you go. Done.
So you sound like you're writing something.
I am promoting. I'm promoting math. 8x minus 4y. 4 take away 16, negative 12 equals 0. You're done. It's just a line. Isn't it? At the end of the day, isn't this line that they've drawn just a line anyways? And isn't the y-intercept that you can see you'll get negative 3? Because x is 0, then when you solve it, you'll still get negative 3 from y1. But now we've actually got the equation. Up there, you don't have the equation. That's why he didn't know what the x-intercept was. But anyways, all good? Ezra, happy with it? Comfortable? Done. Part 2 done? Part 2 done. So same, locus, doesn't matter what you get. I'm trying to show you. Usually z equal to x plus iy. Some you can memorize, like circles, args, but other ones you don't need to memorize. Next one is arg. Arg means it's a ray or an angle. So sketch the following on a complex plane. Arg of z plus 2 is equal to pi on 3. That means the angle is equal to pi on 3. True? Isn't arg angles? So the angle is always 60 degrees. But where does it start? Exactly like your circles, it says z plus 2, negative 2. Because remember, like your circles, it's going to be negative, opposite. Negative 2 and 0, and open circle. Why is it an open circle? Because you can't inverse tan B on A. Sorry, you can't inverse tan, because right, arg is inverse tan. We all agree with that? Inverse tan 0, like it doesn't matter, 2 on 0. You can never have on 0. But it doesn't matter what it is, where it is, it'll always be open circle. So make it open circle. What do you want to say? Because you know every year I get one person that always slips through the crack and just goes, I forgot about it. Don't forget about it. Don't say you forgot about it. Open circle. All right, and then I think you guys can see the other one. It says an inequality, the angles between 0 and pi on 4. And you can see I've shaded literally between 0 and pi on 4. And it's at 0, 0 because it hasn't been shifted anywhere. And no Queenie, all good?
Yep.
Okay, you guys, yes, done, move on. Horizontal, vertical lines, come on, they're just ridiculous. If I told you, draw me the real of z equals to 3, what's the real of z, what letter to you? X, so isn't that the same as saying x equals 3? Does that look like an x equals to 3? Yes, it does. That looks like a y equals to 2. Oh yeah, a plus ib, a plus iy, whatever. True?
Yeah.
If I told you draw me the real of z, done? Imaginary of z? Yes. Any questions? Move on. Move on. Algebraic method. Many other curves will need to be simplified algebraically until we can recognize their details. With practice, most will become pretty obvious. So that one there, I just told you it's not a perpendicular bisector because you put a number in front, it doesn't become a perpendicular bisector anymore. But you prove it. Have a read of the first few lines. Tell me if you've got any questions. Z minus 1, that means you subbed in x plus iy. You did the modulus, you square rooted, did the modulus, square rooted. Then you square everything. So squared, squared, squared. 2 squared is 4. Use brackets, expand, and you end up with this. Sounds good? Any questions? Then we end up with this. It's a circle with center -5 on 3 and 0 with radius 4/3. So all he did was obviously complete the square from here. Yeah, divide by 3 because it's got to be monic and then do whatever you got to do. Any questions, Ben? Everyone's fine with that? So what do we do with locus? That's it. That's the thing you want to take out from it. Z equals to x plus iy. You should know your circles. They do help. You should know your arguments. They also help. Because those are the ones you're probably going to get tested on. These are the ones that many don't get. And I'm guessing it's his last one. Because really there's nothing after that, is there? No, see? It's always his last ones that you got to be careful of. These ones are weird. I don't expect you to understand it straight away. But don't run away from it, because you know this is the one that will probably differentiate you again from your peers. This is the 9900s that we're talking about. Let's do it. A common textbook question from the old syllabus involved arcs, although it was not used in the HSC. Oh, there you go. He would know. It wasn't used in the HSC. They never tested it. Although circle geometry has now been dropped, it is still assumed knowledge from stage 5. So, in theory, it could appear. So, we've seen that when a vector is divided by another vector, that we subtract the arguments, correct? So this means the following types of equations are interchangeable. So if we've got the argument of something minus the argument is equal to theta, it's technically the same as saying arg of the two numbers divided equals to theta. How do we draw these? These equations describe a major or minor arc of a circle. So that essentially means, just so you guys can see what an arc looks like. So like this would be the minor arc, and then the top one would be the major arc. Cool. Continue. Where the 2 points Z1 and Z2 are on the circumference of a circle, and where the angle within the segment measured at the circumference is theta. You'll see this a little bit better with the diagram right there. Just look at it for a second. You'll find either the minor or major arc, not the whole circumference. So it's only the arcs. So you're either going to find the top one or the bottom one, depends on the angle. But that's where theta is. Any questions? No? You sure? Okay.
So
Tell me.
So under the x-axis.
Yes, that would be the minor arc. The top one is the major. Because it's bigger. That's all. If it was the other way around, the bottom was larger, then you would say the bottom one would be a major, the top one would have been a minor. Sounds good? But Z1, Z2 are the points on the x-axis. Z1, Z2. Okay. In drawing the arc, it may be of assistance to remember that the angle at the center must be twice as large as the angle at the circumference. The angle at the center must be twice as large as the angle of circumference. That's a circle geometry theorem. So, but again, there is no more circle geometry, but technically we don't know. So, and that's why we got to teach it still. And that is the apex angle of the isosceles triangle whose base vertices are Z1, Z2. That means this, isosceles triangle. See that? And the bases are Z1 and Z2. Move. So, some other drawing hints. You need these. Imagine standing at the second listed point and facing the first point. So, imagine you're here and you're facing Z1. Cool? So what I might do is do this real quick. It just makes it a little bit easier to see when you're going through the hints and seeing these. Okay. Z1, Z2. So imagine standing at the second listing point and facing the first point. So you're facing this way. If theta is positive, then you want the arc on the left. If theta is negative, you want the arc on the right. If theta is plus or minus, then you want a mirror image of the arc, so not a whole circle either side of the chord. If theta is, it'll come. I think it's sometimes also better to review the notes once we look at some questions, but you'll see what this means in a second. If theta is 90 degrees or less as well, the center of the circle will be on the same side as the arc you want. The center will be at the same side as the arc you want, and you'll have a major arc. So if theta is less than 90 degrees, you'll have a major arc. Obviously, if theta is greater than 90 degrees, you have the minor arc. If theta is positive, then you want the arc on the left. If theta is negative, you want the arc on the right. All right.
When you find negative and positive,
You'll see it. You'll see it. Once you have found the center, you can draw an arc from one point to the other, and you have the curve. So that means this. If theta is positive, you're going to go like this, to the left. Facing this way, you're going to the left. To the left. If theta was negative, you're going to go to the right, because remember, you're facing this way. Does that make sense? One more time. You're facing this way, so think of yourself facing this way. It's really important that you see that. Facing this way. If theta is positive, then you want your arc to your left. So which one's going to be the one to your left if you're facing that way? The major one. Can you see that happening? And if obviously if your theta is negative, you want your arc on your right.
I think I get one.
You think you get it now? You want the arc on your right. So because there's two arcs. There's the top arc or the bottom arc.
Yeah. Wait, I still don't understand what it means by theta positive theta.
Oh, you'll see that because the question would have said, draw arc z minus 2 on z minus 3 is equal to negative pi on 6. That's negative.
Oh, okay.
Or pi on 6 would have just been positive. Rub. Very important. Z1 on Z2. Z1 on Z2. Z2 is on the left. Z1 is on the right. No matter what. Because there's verticals as well. We'll see. If we have a problem with if we see verticals, I'll talk about verticals as well. So like this one. Just before I show you the answer. Z plus 1 minus arc of Z plus 4. So as long as we agree now, we know that it's not a ray. It's not a ray. It's not like it's not like a normal arc. It's not like that. When you subtract, it becomes an arc. You need to work out, is it a major arc, minor arc? Where the heck do I go? Where do I start from? Where's minus 1? Where's minus 4? Blah, blah, blah. Well, now, it's minus 4's there, minus 1's there. We agree with that? It's telling you it's pi on 3. This bit here told you if it's pi on 2 or less, then it'll be on the same side as the arc you want. The center will be on the same side. That's great. The center will be on the same side as you, and you'll have a major arc. Correct? And this one up here also said if theta is positive, then you'll definitely be going to the one to the left, which is still going to be your major arc. The problem is if theta is negative pi on 3, this one says go to your right, but this one says you'll have a major arc. So it's not a minor arc, it's a major arc. Whoa, anyways, you'll get that in a second. So there it is. There's your negative 4 to negative 1 major arc, and the angle here, which is the one we actually want, I don't know why I didn't draw that, is pi on 3. So maybe have a read of his solution and then talk to me if you've got any problems. Otherwise, I think the best thing with these is just exposing to all the different cases. But any questions? Not yet? Anything you don't get from that?
I get it now.
You get it?
Yeah.
You're facing to the right, you're going, let's see what he said. So the arc and facing, we want the arc on the left since the angle is positive. So we want the arc on the left. Okay. And it's got to be a major arc. I guess so. We have seen that if theta is between 0 and 180, that the argument is equal to theta gives an arc. But if theta is 0 or 180 degrees, then we actually get part of a straight line. because the angles add up to 0. So I think they look like this from memory, but let's have a quick look. If theta is equal to 0, then the vectors to z from z1 and z2 have the same argument. True? Because arg of z minus z1 minus arg of z minus z2 equals to 0, technically doesn't it mean these two arguments are just equal to each other? Right? So if the angles are the same, this only occurs when z is on the line passing through the points, but outside the 2 points. I think what I just said. I'll show it to you now. This one, if theta is equal to 0, it's like this. There's z1, let's call it. There's z2, hypothetically, and that would be a 0 case. If theta was 180 degrees, it'll point in opposite directions. This only occurs when it goes through the points. So obviously I think you understand if it's pi, which I have never seen, just so you guys know. I've never seen it being 0 pi, but that would be pi. I think he just put it in there because his teaching teaches, but that's okay. I'm going to continue. And then there's all these beautiful questions. All right. Pick. What do we want to do? Question 1. You want to do it first? Or you want me to do it? Okay, question 1. What is this? Just by looking at it. It's a circle, center is 0, 0, radius. I'm happy with that. Any questions there? This one is what? Also circle. Negative 1, comma 1. I think you're right, because that's minus 1 plus I. Yep, I'm happy with that. And then negative 1, 1. And what's your radius? 1. So it has to touch these points. And then it's saying less than or equal to 1. I can guarantee it's just going to look like that. Easy? Do you want to try some now? Or not yet?
Let's try PNT over here.
Yeah, whichever one you feel comfortable with. Everyone can be doing different ones, I don't mind. So whichever one you feel comfortable with, try it and we'll check them. That's it. Whichever. Out of those 8 questions that you can see, do any ones you like and then talk to me. We'll do that for about 5 minutes. And then that's it. Looks like next week's vectors. I'm going to do your speed tests and... Sorry?
I'll be finished complex numbers for next week then.
So next week we'll do vectors of complex number vectors, and then and then we're done. Correct. Are you happy with that?
Yeah.
Why? Why are you saying, oh yeah? Do you want to do more?
I still need to catch up on last week a bit. I need to do...
Last week, what was last week? We did roots of unity.
Yeah.
Right. Okay. Yeah. So then I might, if you guys feel like, no, Sam, I don't want to move on to vectors just yet because of your first exams, I'm okay with that. We'll just, once we finish off complex vectors, we'll just review. We'll keep reviewing.
That'll be good.
Yeah, I don't know. So we're going to go through these 2 questions. We're going to go through some more homework. We're going to go through speed tests.
Could we start speed tests for complex numbers as well?
Should I start speed tests for complex numbers? Let's do it. Yeah, so let's add, how about this? I'll reduce integration. So I'll reduce it to, let's say 3 questions. I'll introduce 3 or 4 questions of complex. Sounds good? So I'll reduce integration. So then that way it's still within a 10-minute time.
So it took us like 3 weeks to get used to like the integration speed test.
Yeah.
And then like our exams.
Yeah, you're right. It's going to take 100%. It'll take about 3 weeks for you to get used to complex numbers. Yeah. You're right. Done. I like it. Let me make a note of that. Speed test. Well, do you want to do that from today? I'll just make a speed test right now. I'll put just basic complex numbers. I'll put it in there, and that's it. We'll have integration with complex. Done.
Are we gonna stop the time all over again, or are you gonna continue?
What do you mean?
Like,
Oh no, we'll do it at, like I said, I'm going to do it at around a 12 to 14 minute time slot. No, so I'm not going to start the time again. You're going to get fast. That's how it's going to be. You'll thank me later. You need to. You need to just increase your speed. That's it. I can't do anything about that. Done. Let me go grab the other laptop then. I'll start. So, yeah. I spoke to a lot of teachers across the state, especially the top schools. Average for their prelims were 30%. I thought I'd let you guys know. So you're not doing bad. It was really bad across the whole of New South Wales. And I'm talking about probably the top 10 schools in the state. On average, they get 80s and 90s. Sorry?
Average was 30.
Yeah, I can show you the messages and everything. People were like, whoa! And then I said the same thing, like, yeah, I didn't do too well. But like we all know, at the end of the day, we all get band sixes. So it doesn't bother us. It's just that we were just wondering, does that mean we set the papers too hard? Did we assume too much from year 10? That's assumed knowledge for year 11 and 12, and we didn't, there's not enough. So this new syllabus has been a little bit funny. I guess the whole state's still trying to adjust. And that's probably why I think the advanced paper was like a bit like this. But anyways, sorry, Enoch, did you say something?
I was going to say my school's extension one average is 64.
Yeah, maybe I was talking about the top schools. So like maybe your particular school, the test was easier. You've got to keep that in mind. So I haven't seen it yet. If you send it to me, I can tell you straight away if it was hard. Like maybe I told you straight away when I saw yours. Yours was one of the hardest ones I've seen. So it would make sense why there would be a low average there.
And that was 13%.
13% average. Yeah, there you go. But it was a hard exam. That's just so. Anouk, I don't know. You might have got 90. Fantastic, but if it was an easy exam, you've got to be careful. It doesn't mean 90 is 90 anymore. So, just like again, standard kids yesterday, they would have walked in, and even the top students that were getting 95 plus would have struggled to get an 80 yesterday. Really, like so. You don't know. There was no scaffolding, pretty much. Let's just say that, and even in advance, they're removing scaffolding. That's the biggest word you want to remember. There's no more spoon feeding. That's pretty much what happened yesterday, right? In your advanced paper, you would have felt they go just like do it, which is good for us because that's how I train you. I just say do it. Stop talking, stop thinking, just do it. So it's good for us, but usually there's an I, double I, triple I, whatever. For those students that were used to that, it wasn't going to be a good paper. Yeah, so it is what it is. So Anouk, when you get it, send it. I'll tell you my thoughts. Let me just organize the speed test for us. Speed test, let's get that out of the way. Where are we? 2020. Do you want the advanced papers, advanced solutions? You want to,
Let's go through and then just make sure I'm not doing this.
I'm ready for a competition.
Yeah. Okay. So, we're in trouble. Standard or advanced answers.
Does it ring a bell? How does it feel when you look at answers? It feels weird, right? You just did your paper yesterday. All right. Same thing for you guys. Once you finish that night, I'll have it done. If you want your answers, you can have them. If you don't, forget about it and just wait until after your papers are all done. I can give them to you.
Look at it after.
Huh?
Just want to relax.
Yeah, I know. That's what I'm
Get
saying.
that text message, my ATAR.
That's it. I think that's the best way. I thought the same, but I just couldn't. I was like, I need answers, I need answers, I need answers.
I don't know how people remember the questions. I walked out of the exam, it just,
Go on.
I don't remember anything that happened.
But once you see it all again, it kind of comes back to your head. You remember now? You remembering some questions?
I think I got one wrong, multiple choice.
Oh, that's okay. One's okay. Hey, well, it
That's
happens.
the line, right?
Yeah. Okay. And integration now.
We had our first extension 2 lesson today, and apparently we're also going to be using the Steve Howard textbook as well.
Okay, fair enough.
Like it's on the road.
Kind of crap. I mean, it's good,
Yeah.
but it's crap.
We have 3
Because
lessons.
as you can see, some things I haven't even used. I'm like, yeah, crap, move on. But I mean, it's good because at least you get to already understand how he's going through and I'm going through it. I would say exams still. Once you can, jump straight into exams. What were you saying?
We've got 3 lessons a week now.
3 lessons a week.
Of extension. 2.
Good,
3.
I guess.
But he's put it like Monday after school, Wednesday during lunch, and Friday after school.
That's annoying.
Yeah.
So you don't need to attend. You're already good for it. If only, right?
If you do well extension 1 and extension 2, that won't.
And my construction teacher still don't let me drop.
It doesn't let you drop.
No.
They're out to get you in. She won. He's got to
So
win now.
just finish our project now, and then it was some, and I've got to help the other people do it. And then there was some.
Fair enough. I'm doing a hard one today, just to see how you guys find this.
And when you use them, I don't remember anything from integration.
That's it. No, you do. Don't underestimate the power of that little brain.
Integration, so
All right. Let's go through some of these locus questions that you've got first, and then I'll change computers. Questions? Or you guys just want to straight go see the answers to the questions you've done? Or question numbers? Question 2, that's the answer. Or it would have been a straight line going through 0. Is that right? Is that what you drew? A straight line like y equals maybe x, 2x. Looks like it's y equals x actually. But I don't know. No? Confused?
I did the make z equal x plus.
Yeah, correct, which is the right way.
Yeah, and then I got negative 4y equals 0.
Negative 4y. Z plus 1 minus I, z minus 1 plus I.
See, I was thinking that way, look at it.
No, don't do it that way. Don't worry. Z plus 1 minus I equals, what was it? Z minus 1 plus I. So that should have been square root of x plus 1 squared plus y minus 1 squared is equal to square root x minus 1 squared plus y plus 1 squared. Is that right? Is that what you got?
I think it's square root 1. Square root.
Yeah, because they cancel out. Okay, x squared, y squared cancels out. 2x is 4x. Minus 2y is minus 4y. 1 plus 1 cancels out with 1 plus 1. Like I said, x equals to y. Had to.
I cancelled out a couple of numbers that weren't supposed to be cancelled.
I'll cancel a couple of numbers. Can't do that. What do you mean? All right, what I might do actually for you guys, I'll just print this. At least that way, you have it here. Anyone else want to check any other answers? Anyone else want to check anything else? No? All good? Close it up. Save that. I'm going to move laptops. So let's open it up here. Skype. While it's doing its thing, let's just go here. Control V. Control X. Control V. And Control X. Control V. Control X. Control V. Okay. All right. You want me to print them? You want to go through it slowly? Okay, fine. Do you want to see extension 2? There's only answers right here. I've got the paper up.
How long does it take for the?
Me to do it?
No,
That's a good question.
things to come out.
Paper? I think that should be out tomorrow.
No, not the paper, the actual marks, like the paper.
December 17th.
Just not too long.
Yeah, about a month or so. A month and a bit, 6 weeks. Okay. No, it might pretty quick. There's 16 teachers. Sorry? They mark the whole state, correct. So, for example, one marker would mark question 11 and that's it. And then the senior marker would just, there's 2 markers, or markers, so just double check. And then if there's any discrepancies or there's any problems with the senior marker, you just go to and say, all good, do I mark this right, is this wrong, this method I've never seen before, because that happens.
Yeah.
So the people that are usually chosen only had to have at least taught that particular subject, I would say, for the last 5 years and only that subject, which is very rare to find.
Yeah.
So that means, like, generally your teachers will teach, let's say, a Year 8 class, they can't become HSC markers. You can only be teaching HSC for the last 5 or 6 years consecutively. And that's what I mean with extension 2. Extension 2 teachers, your teachers, not all of them have been doing it for the last 10 years. I have. That's why I'm aware of extension 2. Whereas once you stop with extension 2, it's so hard to come back to it. So I haven't stopped, and that's why I could teach it in that particular way. That's why with advanced, I've always, for the last, how many years I've done, I've always taught advanced, I've always taught extension 1. General math? No, I haven't, so I don't know it very well. Which is why I say it, like, you guys just do it my way, you'll be fine. The teachers, it just depends on the timetable. If it works, they get in, they do advanced. If it doesn't work, they do Year 8, they do Year 10, they do this. So. All right. Let's get to this printer for you guys. You're lucky because it looks like it's frozen. The problem with that is that if I close it, because I know it's going to happen. If it didn't save, I will not be very happy. So we'll wait and see. Please just say restore. Just say restore. Just do it. Say restore. No. There's one question. See how these are all organized by topics already? That's what I mean. You want exam questions. Oh, I'll give you homework as well. doing it. All right, we'll reduce it to these two. But that's everything we've just done today with Locus. Print 4 copies for you guys. All right, Anouk and Queenie, I'll save it. I'll send it to you guys if you want to keep it there. Speed test, complex, and integration. It will still take 10 minutes. Take 10 minutes because the integration is going to be long. What the heck are you talking about? Don't get antivirus. It doesn't work. All right. I'll get this printed and come back. Stop staring yourself. Okay, you can start. You can start. You can start. You can start. 10 minutes. Starts. Now, let's send it to these guys so it's fair. It's very strange. X, I'll give you guys a clue. Remember, x equals u squared, dx equals 2u du. Then don't forget to change your limits and then just substitute. That's two different parts, by the way, I and double A.
I can't see the paper.
I've just sent it to you on Skype. Did you get it? Right there.